All right, gang. We're going to continue on with section 5.4. We've been working with exponential equations and also with logarithms. And what we're going to do, what we're going to continue with in this section is looking at how to solve those equations when it contains a variable. So as a refresher, we said in the last lesson, if we had a logarithm, right, it asks the question 3 to what power is 9. We know that that answer is 2. So we have the log form of a logarithm, and then we also have the exponent form, which is the equation is still true and it's still saying the same thing. So 3, of course, to the 2 equals 9. So I want to make sure that we can move back and forth with this. So for instance, if I had an x here, let's just say we had log base 2 of x equals 8, for instance, or equals 4, something like this. And now the question is, so we have a log in log form, but now we want to solve for x. Okay? So we know that if we rewrite it in exponent form, that this x is no longer going to be inside the logarithm. If we rewrite, we're going to get 2 to the 4th is equal to x. And so that's 16, 2 to the 4th is 16, but now we've solved for x. So by rewriting, by having the freedom to go from log form to exponent form, or exponent form to log form, you can then change the equation and rewrite it in a way that we don't have the variable inside the log and we can solve. So let's try another one. Let's solve, we'll call this example 1. Let's say that we have log base 3 of x minus 1 equals to 2, okay? And we want to solve for x. All right. So once we have it, a logarithm in this form and log form, what I'm going to do is I'm going to rewrite in exponent form. Now I can only do that once I get it to where the log is by itself. So maybe one step before that, I might like to say, so maybe step 1, isolate the log, and then step 2, rewrite in exponent form. So if I'm going to be clear on those steps. So the log is by itself. And so if I rewrite it, we know we can rewrite it. 3 to the exponent should equal to the inside. So 3 squared is equal to x minus 1. This is where I'm rewriting. Okay? And now I have it in a form that allows me to isolate x. So now I can solve for x. 9 is x minus 1. And if I add 1, I get 10 is equal to x. And just to go back and check, if I plug in a 10, it should make that equation true. Okay? All right. Maybe you might have a little bit something more in front of it. So maybe on example 2, maybe you have 3 plus 2 times log base 2 of x equals 4. Let's say we have something like this. Okay? You have a little bit more. So again, first step, isolate the log. Second step, rewrite in exponent form, and that should allow us to then solve it. So now if I want to get this by itself because I'm eventually want to have it just a logarithm. Okay, just like this, okay, so that I can rewrite. So my first step, if I'm trying to isolate this, would be I would subtract the 3. So I subtract 3, we get a 1. All right. Now this is 2, in front of a log means 2 times, so I'm going to divide by 2. And I have log base 2 of x equal to 1/2. And there you go. So now, once I'm at this stage, so I've completed step 2, or I've completed step 1. The log is by itself. Now I'm going to rewrite. okay? So it's going to be 2, the base, to the exponent should equal to the inside. Well, that's it. I mean, at this point, I could type it in on my calculator. We know to the 1/2 means same as square root. And there you go. There's your answer. And that's the best method for solving log equations, okay? So now what we're going to do is we're going to basically do the reverse. We're going to solve exponential by getting exponent form, right, and then rewriting it as a log. So let's look at how we would solve an exponential equation. So just like this, we know 3 squared is 9 is the same as saying this. If I had 5 cubed is 125. So if I have an exponent, I know it can be written, the base of the exponential is the base of the log. The exponent is the right-hand side, and then the 125 should be on the inside, because this is asking 5 to what power is 125. So that's how you would rewrite it. But my point is, so I had 2 to the x equals to 8. I could write that as a logarithm, log base 2 of 8 is equal to x. And now I've solved for x. Now, hopefully you know the answer anyways here, that x is 3, right? But this is a way to get x by itself, and you may need your calculator, because you could have had something like 3 to the x equals 17. Well, we don't know what that power is. We can guess. So if I rewrite it as a log base 3 of 17 equals to x, you have the capability to type this in on your calculator and get a decimal, okay? So let's look at solving some exponential equations. All right. So we'll call this example 3. We still want to solve for x. All right, and let's say we have 2 to the x minus 1 plus 4 equals 11. Okay, so there's our exponential equation. Okay, so now when we want to solve, when solving exponential equations, we're going to isolate the exponential part. So in this case, we're going to isolate the 2 to the x minus 1. And then after we isolate, we're then going to rewrite in log form. Okay? And that will allow us to then get x by itself. All right, so let's look at this. So first step, if I want to isolate, I'm going to subtract the 4. Now I get 2 to the x minus 1 is 7. So now, notice it matches exponent form. You have a base, you have an exponent, and you got the right-hand side. So now I'm going to write it as a log. I'm going to write it as a log. So it'll be log base 2 of 7 equals x minus 1. And once I rewrite it, then you can see the x is no longer in the exponent. I can get x by itself by adding 1. So log base 2 of 7 plus 1 is equal to x if I add 1 to both sides. And then you can type this in on your calculator. Remember, if you don't have the base 2 button, you can do the change of base, log 7 over log 2 plus 1. And that should be our answer. We can get a decimal answer from that. So let's see what we get. Log 7 divided by log 2 plus 1. So I've got 3.807 if I'm rounding to 3 decimals. Okay, and we'll do one more. I'm going to do, this time I'm going to use the natural base e. So let's say we have 3e to the x plus 2 equals 14. Let's just say that's what we have. So I'll isolate. So we're still going to solve for x. All right, so my first step, I'll subtract the 2. So 3e to the x is 12. Again, I'm trying to isolate the exponential part. I then divide by 3, so e to the x is 4. All right, so remember now when we go to write this as a logarithm, it's log base is going to be e of 4 is equal to x. Well, we know that log base e, that means ln. You could just simply type in ln of 4 in your calculator, and we get 1.386. Okay, so that's the extension of the 5-4 work on solving exponential and logarithmic equations, and I hope that this helps you, and we'll continue on from here next week. Thank you.